All right, so here we are with a question that says, I've got this equilibrium SO2 plus NO2 goes to NO and SO3. I'm giving you concentrations of gases in a flask, and I'm saying, is the reaction at equilibrium? In order to solve this problem, I think it's important to recall that when we write the concentration of products over the concentration of the reactants raised to their stoichiometric coefficients, this is called a reaction quotient. Q. Q is only ever equal to K, the equilibrium constant, when the reaction is at equilibrium. So generally, in the general sense, when I do this, it's called Q, the reaction quotient. So if I were to write the concentration of the products over the concentration of the reactants raised to their stoichiometric coefficients in this form, then this only equals the equilibrium constant when this reaction is at equilibrium. And I give you the equilibrium constant, it's 85.0. So what I want to do is I want to actually figure out what the value of Q is, because if the value of Q equals 85.0, then the reaction is at equilibrium. So I'm going to go ahead and I'm going to stick in the concentration values that I get. So I got 0.0250 for SO3, 0.040 for NO, 0.00350 for SO2, and 0.00250 for NO2. I'm going to run that through my calculator and write down the number. I get 114.3, 114.3. Okay, so is the reaction at equilibrium? Well, is 114.3 the same value as 85.0? No, it's not. So then clearly the reaction is not at equilibrium. Okay, so now that we've decided it's not at equilibrium, which direction will the reaction proceed to arrive at equilibrium? So remember, in general, it's the products divided by the reactants raised to their stoichiometric coefficient. If Q is bigger than the equilibrium constant, then that means that I have more products than I need. So if Q is larger, then that means that the numerator is bigger than it should be in order to be at equilibrium. So if the products are too big, then in order to compensate, I'll have to make more reactants. So which way is it going to shift if I need to make more reactants to reach equilibrium? It's going to shift towards the reactants. It's going to shift left. It's going to shift left. And so that's the final answer. Reaction's not at equilibrium. It's going to shift left to get there. And that's, in calculating Q, is how I decided it's not at equilibrium. Okay.